All right, here's 4 or 5, multiplication rule. As you saw in my last video right at the end, I talked about the probability of at least one, only briefly to give you that foreshadowing and maybe that teaser, if you will, of the excitement that's to behold in section 4 or 5. So find the probability that among several trials, we get at least one of some specified event. We're going to define to the conditional probability, which we've already been talking about, but I just want to make sure you get more acquainted with it. So complement the probability of at least one. At least one is equivalent to one or more, by the way. So the complement of getting at least one item of a particular type is that you get no items of that type. Okay, think about that. Of getting at least one, the complement of it is you get none, right? So if you think about it like a test or an exam, right? What's the probability you get at least one correct on a 5-question test or quiz? You could get 1 question right, you could get 2 questions right, you could get 3 questions right, you could get 4 questions right, you could get 5 questions right. You have to add all those probabilities up, and that would give you the probability of getting at least 1 right. But you could also do 1 minus the probability of getting none right, and that'll give you the same thing. It'll give you at least 1. And that's the whole idea here. At least 1 is going to be equal to 1 minus the probability of none. It's a really powerful calculation. You should write this down in your notes and be familiar with it, because we will use it later. Okay. Topford supplies X data DVDs and lots of 50. And they have a reported defective rate of 0.5%. So the probability of a disk being defective is 0.005. It follows that the probability of a disk being good then is 0.995. Okay, what is the probability of getting at least one defective disk in a lot of 50? Holy smokes. If we were going to do 50 individual calculations to get that, right, you could have 1 defective one, you could have 2 defective ones, you could have 3 defective ones, you could have 4 defective ones, you could have 5. Okay, you're probably wondering why I keep going. You could have all the way up to 50 defective ones. That'd be 50 different calculations. The complement and the probability of at least one makes it so we only have to do 1 calculation. And that's basically all 50 disks are good. Because right here we're looking at least 1 defective. So 1 minus the probability of no defective ones, right? All good. We can just do that, and that's how we can solve it. Much easier calculation, really powerful. By the way, it's not unusual for us to get at least 1 defective one. That's why. All right. Conditional probability, we've already kind of talked about this, but conditional means the probability of event B occurs given A has already occurred. So again, like I said in the last video, I said, hey, you can do some simple algebra and you can multiply or divide and move stuff over. Like if I multiply this A over here, then we just have the probability of A and B. We have probability A times the probability of B given A. So you can see, pretty cool little thing that we can do with algebra, moving stuff around. Intuitive approach to conditional probability. So this is just kind of make you think intuitively how you calculate these things. The conditional probability of B given A can be found by assuming that event A has occurred and then calculating the probability event B will occur. So in this case, if somebody said, refer to the table to find the probability that subject actually uses drugs, given that he or she had a positive test result. So given you're in the positive test result, what is the probability they are a user? So we sum this total up, which is 190, which is 134. And then we do 44 divided by 134. And that would give us the probability that someone actually uses drugs given that he or she had a positive test result. So here, on the next slide, subject uses drugs given positive test result. We can do the formula like I did it intuitively. Given you're working in this intuitively, you're working in the positive drug column. So that's how I got the 134 down here. And then 44 divided by 134. Now, if you want to show mathematically how to find it, it's the subject uses drugs and subject positive. So that's 44 out of the total thing here, which is 1,000. That's this numerator part. And then we have the denominator piece down here. Subject test positive. Well, positive result is going to be this column here over the whole entire thing. And then, well, when you have 2 fractions and you're dividing them, you multiply by the reciprocal. So that's how we get the 44 over 134. Pretty cool, huh? Yeah. All right, confusion of the inverse. It's really important. So B given A does not necessarily equal the probability of A given B. So, for example, if we go back and I use my silly shoe coming untied and you tripping. So in this case would be the probability you trip given your shoe came untied. That is not going to be the same thing as the probability your shoe came untied given you tripped. So they're not necessarily the same. And if that's not very clear, here's a better one maybe for you. Consider the probability is dark outdoors given that it is midnight. So dark given midnight equal 1. You can conveniently ignore that Alaska winters and other such anomalies, okay? But the probability is midnight given that it is dark outdoors is almost 0 because you have to be exactly on midnight, by the way. So probability dark given midnight is equal to 1, but the probability of midnight given it's dark is almost 0, right? If you walked outside and it was dark outside, you couldn't probably pinpoint what time it was even. Probably would be just guessing. So this is where basically hopefully you see that they are not equal and you should not assume they are, okay? And now 4, 6, and that's it.